Today, we're diving into the fascinating world of artificial intelligence and its impact on the energy industry. You have likely heard experts and industry leaders talk about how AI is transforming various sectors. Let's focus on its applications in energy efficiency. I'm thrilled to share with you some incredible insights we have gained over the last 3 years at UNC Charlotte. We have been working diligently to model the behavior of energy efficient buildings and to optimize a critical metric known as EUI. But first, let's demystify EUI. Energy use intensity or EUI is a key metric in the building industry. It essentially expresses building energy use as a function of its size and characteristics. To accurately model EUI, we have deep dived into a treasure trove of data sources including monthly utility bills, sensor data, and extensive site visits to thousands of commercial buildings across the nation, each facing diverse climatic conditions. EUI has become an industry standard because it simplifies the understanding of buildings' annual energy performance, and it's great for human interpretation. However, relying solely on a single number can be limiting when we want to analyze performance on a more granular level like daily or monthly basis. A single number also causes a lot of issue when we're trying to model all the energy consumption parameters into one number. But models do substantially better when we split the single number EUI into 12 months. Now, let me share a captivating case study that illustrates why we need models capable of accurately capturing and labeling all the dynamics of the building. Sometimes, seemingly small changes like adjusting temperature set points can lead to substantial revenue loss and discomfort for building occupants. Here's a real data from one of our site visits where the heating set point was lowered by just 5 degrees Fahrenheit over 3 months. Witness how this seemingly minor change had a significant impact on heating runtime over time. For more in-depth information on this case study, I encourage you to explore the published paper, which was generously sponsored by Sloan Foundation at Duke University. AI has been making significant strides in modeling complex dynamics, and that's why we have integrated these methods into our research. When dealing with few features that drive energy consumption, models like decision trees excel in identifying patterns while remaining interpretable and being less complex. However, when we encounter complex structured and tabular time series data like this, extreme gradient boosting, or simply known as XGBoost models like gradient boosted decision trees and random forests shine in handling regression analysis and in identifying indicate patterns. But here's the catch. These complex models are often considered as black box models. To address this, we turn into feature importance within XGBoost for interpretability. This tool gives us an initial understanding of model performance, but it's not without its challenges. For instance, the model might rank the number of occupants as more important than the relationship between outdoor and indoor temperature, which contradicts our research findings. A human expert can easily identify and correct these issues. This scenario highlights two critical considerations. A model should comprehend the data's complexity but also be interpretable by a human expert. This brings us to a very intriguing problem, symbolized by a seesaw that you're seeing here. On one side, we have models like XGBoost and deep learning, which offer exceptional predictability. On the other side, we have models like decision trees and Bayesian models, which provide outstanding interpretability. What we aim for is to find that sweet spot in between. This is where one of the hottest data science fields come in, that is interpretable AI. Introducing interpretable AI, also known as explainable AI or XAI. This interpretable AI allows us to get the best of both the worlds. Over the next year, we are incredibly excited to see where our research will lead as we leverage years of labeled data and apply the principles of XAI to tackle complex problems. This journey will eventually accumulate into my final dissertation. Thank you for joining us today on this fascinating exploration of AI and energy efficiency.